Hey guys! So today we will be touching on a bit of matrices, just the basics, and we'll be perhaps doing a couple of questions at the end. So let's get into it. Matrices. Matrices. That's plural. Now, if you want the singular form, it can be written as the word matrix, which is Matrix. Now, the reason I did not want to title this topic Matrix is because I don't want students thinking it has something to do with the movie. All right, guys. So exactly what is a matrix? Well, a popular definition you'll hear is that a matrix is simply an array or list of numbers. So if you ever wanted a definition, there you go, an array of numbers. And they tend to be enclosed in some brackets, enclosed in some huge brackets, as I will show you just now. Okay, so an array of numbers enclosed in brackets. Now, exactly what does that word array mean? Because you see, we can have brackets, we can have some brackets, and we can write numbers in them. I mean, you can write numbers, any way you want, and that's some numbers in brackets. But the word array means a particular order or a particular arrangement of these numbers. And that's the key component in understanding the layout of what a matrix actually looks like. So this is not exactly a matrix. It's just a group of numbers in brackets. An array of numbers looks more like this. So for example, say I can have 2. Let's throw in some negative numbers there. I can have 0 and I can have 5. So in total, we have 4 numbers enclosed in brackets. It's an array because it's aligned, But how are they aligned? Are there words to describe these alignments? Well, yes. If you guys can remember, when you are writing numbers horizontally, going in that x-axis direction, these are said to be arranged in a row. And also, if you were to observe these numbers 2, 0, written one above the other, these numbers are said to be arranged in a column. Oh, I'm sorry. Oh, famous maths teacher. C-O-L. It ain't U. It ain't a column if it doesn't have the U after the L. So we have our rows written horizontally and we have our columns written vertically. And that, my friends, is what an array means. It means that you have your brackets, you have some numbers within them, but an array of numbers tends to be ordered, and they're ordered in rows and columns. So if we were to observe this very same arrangement, and I were to describe this array or this ordering, if I were to describe how these numbers are ordered or arranged, I can say that this has, let's see, this is our row 1, and this here will be our row 2. Similarly, this will be our column 1, and this will be our column 2. So I can say that we safely have 2 rows and we have 2 columns. Now, the thing about matrices is that because ordering is so important, we want to actually specify which one comes first? So for example, if I wanted to describe this matrix to someone and I wanted to say, well, hey, I know it has 2 rows, I know it has 2 columns. I can describe it using a special notation, and it's written like this to describe any matrix. It's described in this format. You start with your how many rows you have by how many columns you have. Let's look at an example. Okay. So let's just say, for example, we were given an array of numbers that look like this. 2, 1, 5, 6, -2, 0. And we had to describe this matrix. Well, then all we need to do is count up, firstly, how many rows do we have? Rows go horizontally. So we have row 1, we have row 2, and then we have row 3. So it seems that we have 3 rows. How many columns do we have? We have column 1, then we have column 2. So it seems we have 2 columns. So we'll write that down. So in a particular order, if we were to describe this matrix would be called a 3 by 2 matrix. And this is how it's said. I'm writing it in words so you guys can say it out loud to your teachers when you're in school. But the savvy way of writing it, pen to paper, you would see that multiplication sign, but that sign just simply means by, and it's a descriptive notation used to describe the order of a matrix. I think I'll do one more. What if we have something that's like this, 5 and -1, and they say, what's the order of this matrix? Can you describe this matrix? Well, it looks a bit tricky, doesn't it? But the rule applies. We're going to first find out how many rows we have here, and we have 1 row. So it's a 1 by how many columns do we have? Well, this is column 1, and similarly, this is column 2. So we actually have 2 columns. So this matrix would be called a 1 by 2 matrix. Actually, I think I'll do a few more because I'm just thinking up some examples, some common examples that I know students tend to get a little bit scared about when they see them, but they're more straightforward than you realize. Let's look at this one here. So we want to identify the order of this matrix. Now, looking at it, you can see that we have 2 rows. Row 1, row 2. So that's 2 rows by how many columns? We just have 1 column. So this is a 2 by 1 matrix. Similarly, we have we can have matrices that look like this, which is the one we did in the first example. 2, 5, 0, 1. How would you describe this? Well, the same principle applies. You count how many rows. We have 2 rows and we have 2 columns. So that's a 2 by 2 matrix. And I'd say at the Form 5 level, you guys would be encountering a lot of 2 by 2 matrices. And at the Form 6 level, you would be encountering more 3 by 3 matrices. So keep that in mind. Now, some points to highlight are that for one, if you ever encounter a 2 by 2 matrix, because the number of rows is equal to the number of columns, they're exactly the same, then they tend to form a square. So this is commonly called a square matrix. Whenever you have the number of rows being equal to the number of columns, it's called a square matrix. And other examples of square matrices can be a 3 by 3, a 4 by 4, a 5 by 5. You get the picture. Same side by side, squares have the same length. And also, we can also have a situation where we have equal matrices. For example, if you have a situation where you have one matrix that looks like this, we have 5, 7, 2, 4, and you have another matrix 5, 7, 2, 4, then it's said that these two matrices are equal to each other. Did I just say matrices? That's hilarious. I meant matrices, guys. Oh, tongue twister. All right, so we have two equal matrices when we have not necessarily square matrices. Let me give another example to clarify that. All right, so for example, if I had, let's just say 0, 1 equals 0, 1, you know, we have two matrices here as well. They're not square matrices. For example, this one has how many rows? This one has 2 rows by 1 column. This one has 2 rows by 1 column. So they are definitely not square matrices. However, they are equal matrices, and they are equal because the number of rows and columns on both ends are the same, as well as they are the exact same numbers. All right, so this is how you would represent equal matrices. And finalmente, on your basics of matrices that you will be learning today is, what is a zero matrix? Da, 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 da. What is a zero matrix? All right, well, what does a zero look like? It looks like that. So basically, a zero matrix is simply a matrix that has all elements being 0. Should I say all elements are 0? So for example, if I were to open the brackets to start and I had a regular 2 by 2 matrix, it would mean that the 2 rows and 2 columns would all contain zeros. If I had a 2 by 1 matrix, if I had a 1 by 2 matrix, if I had a 3 by 3 matrix, oh, that's a, let's just add one down here. You guys get the picture. So pretty much you do have 0 matrices popping up, and they're actually very nice because they help a lot of things cancel out down the line. Okay, guys, so those are all the different types of matrices you would be encountering. And be sure to look in my next video. We'll be moving on to the basic features of matrices, such as how to add them, how to multiply them, and the good stuff. All right, so looking forward to you guys being with me in the next video. Take care and all the best. Bye.